in the last class we discussed about the Kirchhoff's laws. Yes, in the Kirchhoff's laws we discussed the two laws mainly. In that, one is the Kirchhoff's current law and one more is the Kirchhoff's voltage law. Yes, they both are very easy. Yes, in that what you have to do? First, you need to take the statement. Yes, I given the statement there. Two statements I given for the each law. You can take the anyone in that. Yes, and after the statement, diagram. Then after the diagram, that equations. Right. So if he asks you Kirchhoff's laws, then you need to write this much in the paper for 3 marks. What is that? First is statement, letter, diagram and last equation. Yes, so this is about the Kirchhoff's laws that we discussed in the last class. Yes, now we will take the next concept. Yes, again one more interesting topic it is. Yes, very easy it is, and it will be asked for the 5 marks in your exam. Yes, see, not only for the theory part, he may be ask you the problem on this part. Yes, if he ask the derivation, then that will be carry the 5 marks. Yes, if he will not ask the derivation on this, then definitely he will ask the problem on this concept. Right, that means either problem will come or derivation will come for the 5 marks on this concept. So it is a very important concept in our electricity chapter. Yes, we will take slowly this one. You understand it better and again you can solve it easily on your own. Right, let us start our next topic, that is Wheatstone's bridge or network. Yes, here I tell the name, that is the scientist name. Yes, Wheatstone's. Yes, he given the one network here. Yes, that only we called it as Wheatstone's bridge or network. Yes, so ಏನಪ್ಪ ಹಾಗಿದ್ರೆ ಇದು Wheatstone's bridge ಅಂದ್ರೆ? See, it is a one mathematical formula he gave. Yes, from this network he gave the one mathematical formula. Yes, by using that formula we can easily compare the value of resistances. Yes, you can see here one resistance is there and one more, and here R3 and here R4. Yes, how many resistances are present? 4 resistances are present in the network. Correct? So ಎಷ್ಟಿದೆ resistance 4 ಇದೆ. Yes, so ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಈ ನೆಟ್ವರ್ಕ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಒಂದು ಈಕ್ವೇಷನ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ ಲಾಸ್ಟ್ ಗೆ ಡೆರಿವೇಶನ್ ಅಲ್ಲಿ. Yes, by using that mathematical formula we can easily calculate the value of resistance. Yes, yes. So here see, for example, again ಬರುತ್ತಪ್ಪ ನನ್ನ equation last ಗೆ R1 by R2 is equal to R3 by R4 ಅಂತ ಬರುತ್ತೆ. For example, here I will write, this is our last condition, last equation of the derivation. ಹೌದಾ, ಈ ತರ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ, ಮ್ಯಾಥಮೆಟಿಕಲ್ ಫಾರ್ಮುಲಾ. Yes, so if you know the R1 and R2, ಹೌದಾ, ನಿಮಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ R1 ಮತ್ತೆ R2 ಗೊತ್ತಿದೆಪ್ಪ, so you can easily calculate the R3 and R4. ಹೌದಾ, ಈಸಿಲಿ ನಾವು ಏನು ಮಾಡಬಹುದು, ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಕಂಪೇರ್ ಮಾಡಬಹುದು. Yes, and we can also calculate the value of that resistance also. ಹೌದಾ, suppose you know R2, you know R3, you know R4, but you need to calculate the value of the unknown resistance, that is R1. ಹೌದಾ, ನಿಮಗೆ R1 ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿಲ್ಲಪ್ಪ, ಬಟ್ ನಿಮ್ಮ ಹತ್ರ ಯಾರಿದ್ದಾರೆ ಈಗ R2 ಇದೆ, R3 ಇದೆ, R4 ಇದೆ. So you can easily write R1 is equal to R2 into R3 divided by R4. ಹೌದಾ, he said, by using this Wheatstone's bridge, we get the one mathematical formula that we use to compare the resistance or to determine the unknown resistance. Yes, this is the application of this Wheatstone's bridge. He may be asked you for the 1 marks. Yes, write the application of the Wheatstone's bridge. What you will write? It is used to measure the unknown resistance or used to compare the value of resistance. Yes, now we will start the theory part of this. Yes, I will grab that. So, you can see the diagram here. Easy diagram it is. You can identify here what are the elements which are present in our network. Just see here, R1, R2, R3 and R4 are the 4 resistance that we are considering now. Yes, ಇಲ್ಲಿ ಎಷ್ಟು resistance ಇವೆ? 4 resistance ಇದೆ. We given the value R1, R2, R3, R4. Yes, then ಇಲ್ಲಿ point A ಅಂತ ತಗೊಳ್ಳಿ. A, this is B and this is C, this is D. ಹೌದಾ? A, B, C, D ಅಂತ ನೇಮಿಂಗ್ ಕೊಡ್ತೀನಿ. Yes, then A ಮತ್ತೆ C. Here I connected the one cell. ಹೌದಾ? A ಮತ್ತೆ C ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ? ಈ ಎರಡಕ್ಕೆ ಪಾಯಿಂಟ್ ಮಿಡಲ್ ಅಲ್ಲಿ ನಾವು ಒಂದು ಸೆಲ್ ಅನ್ನು ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. Yes, this cell is having what? EMF. Yes, EMF, that is electromotive force. E, that I written here. Right? Then, so cell ಇದೆ. Yes, so cell ಇದೆ ಅಂತಂದ್ರೆ of course ಏನಾಗ್ತದ? ನಾವು energy supply ಮಾಡ್ತಾ ಇದ್ದೀವಿ. For whom? Electrons. Right? This is the wire. So wire ನಲ್ಲಿ ಯಾರು present ಇರ್ತಾರೆ? Electrons. So if we are giving the energy to the electrons, then they start to move. Yes, if they start to move, then definitely there is a production of the current I. Yes, so current I which will flow from the positive electrode to negative electrode. ಇದು ನೆನಪಿರಲಿ ನಿಮಗೆ, ಕರೆಂಟ್ ಯಾವಾಗಲೂ ಪಾಸಿಟಿವ್ ಇಂದ ನೆಗೆಟಿವ್ ಕಡೆ ಫ್ಲೋ ಆಗುತ್ತೆ. Yes, then so ಇಲ್ಲಿವರೆಗೂ ಬಂತಪ್ಪ ನಮ್ಮ ಕರೆಂಟ್. Yes, ಇದಾದ್ಮೇಲೆ ಈ ತರ ಇದೆ ನಿಮ್ಮ ನೆಟ್ವರ್ಕ್. Right, so current must pass through all the points. Yes, so current ಏನಾಗ್ತದ? Split ಆಗ್ತದೆ. Yes, so here it will go first and it will become the current I1. Right, and at the down it will come, it will current I2. Then at point B ಬಂದರೆ ಮತ್ತೆ split ಆಗುತ್ತೆ ರೀ. Yes, ಇಲ್ಲಿ current I3 ಬರುತ್ತೆ and then ಇಲ್ಲಿ move ಆಗ್ತಾ ಇರುತ್ತೆ. Then here it will go and it is the current I4. Yes, and again it will meet here and again it will flow as a current I. Right, then so ಈಗ B ಮತ್ತೆ D point middle ನಾವೊಂದು G ಅಂತ ಬರುತ್ತೆ. Yes, what is G? G is nothing but here galvanometer. ಹೌದಾ? galvanometer ಅನ್ನು ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ನಾವು? You already know that in your 10th standard he given you. Right, so galvanometer will be used to measure the small amount of current in the circuit. ಹೌದಾ? Yes, so ನಾವು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ? galvanometer ಅನ್ನು ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. Yes, so galvanometer ಥ್ರೂ ಏನಾಗ್ತಾ ಇದೆ ರೀ? ಕರೆಂಟ್ ಪಾಸ್ ಆಗಬೇಕು. ಯಾಕಂದ್ರೆ I1 ಪಾಯಿಂಟ್ B ಬಂದಮೇಲೆ ಏನಾಗುತ್ತೆ? ಮತ್ತೆ ಸ್ಪ್ಲಿಟ್ ಆಗುತ್ತೆ. ಒಂದು I3 ಆಗುತ್ತೆ, ಇನ್ನೊಂದು IG ಆಗುತ್ತೆ. G ಅಂದ್ರೆ ಏನು? ಕರೆಂಟ್ ಥ್ರೂ ದ galvanometer. So it will pass and it will meet at the point D and again it will go as a I4 current. Right, so this is about the construction of the Wheatstone's bridge. Right, yes, so after discussing the construction of the Wheatstone's bridge, now see, we will take the one condition here. What is that? Balanced condition. What we will do here? See, here R1, R2, R3 and R4 resistances are present. Yes, it is. So what we will do? We will alter these resistances. ಅಂದ್ರೆ change ಮಾಡ್ತೀವಿ resistance ಅನ್ನ. ಇದರಿಂದ ಏನು ಮಾಡ್ತೀವಿ ನಾವು? adjust ಮಾಡ್ತೀವಿ. ಈ ರೀತಿ adjust ಮಾಡೋದ್ರಿಂದ ಏನಾಗ್ತದ್ರಿ? IG will become 0. Yes, in this network. So galvanometer will show the 0 deflection. Right? ಅದು ಏನು ಮಾಡ್ತದ್ರಿ 0 deflection ಅನ್ನು ತೋರಿಸ್ತದೆ. ಅವಾಗ ಕರೆಂಟ್ ಏನದ 0 ಅದ ಅಂತ ನಾವು ತಿಳ್ಕೊತೀವಿ. That is Ig is equal to 0. So ಅದನ್ನೇ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ Wheatstone's balanced condition ಅಂತ ಹೇಳ್ತೀವಿ. Yes, what we say Wheatstone's balanced condition. Yes, here I will write. Now resistances R1, R2, R3 and R4 are altered by adjusting them, then we can make what Ig is equal to 0. ಹೌದಾ R1, R2, R3 ಮತ್ತು R4 ಅನ್ನು ಏನು ಮಾಡ್ತೀವಿ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ತೀವಿ. ಅದರಿಂದ ನಮಗೆ ಕರೆಂಟ್ Ig ಏನಾಗ್ತದ 0 ಆಗುತ್ತೆ. Yes, so ಇದನ್ನೇ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ it is known as Wheatstone's balanced condition. Wheatstone's balanced condition. Yes, so this is the condition here for the working of the Wheatstone's bridge. Yes, now we see the expression ಅಂದ್ರೆ derivation ಅನ್ನು solve ಮಾಡೋಣ. Expression for the Wheatstone's network. Right, so here just see current I1, I2, I3 and I4 and Ig are flowing through the resistance R1, R2, R3 and R4 and along with the G. Howda? Yes, and we have the balanced condition, that is balanced condition, that is Ig is equal to 0. ಹೌದಾ? Yes. So ನಾವಿಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ಮೊದಲಿಗೆ Kirchhoff's current law ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. Later we will apply the Kirchhoff's voltage law. Yes, so you can write here. See, I1, I2, I3, I4 and Ig are currents flowing through current I1 is moving in the resistance R1, current I2 is moving to the resistance R3, then current I3 is moving to resistance R2, R4 and G. ಹೌದಾ? G ಅಂದ್ರೆ ಇಲ್ಲಿ galvanometer. Yes, and we have our balanced condition, that is Ig is equal to 0. You must remember this. ಹೌದಾ? Yes. Now we will apply the Kirchhoff's current law, KCL law. ಹೌದಾ? ಅಲ್ಲಿ ಏನಿತ್ತು Kirchhoff's current law ನಲ್ಲಿ what we did, we seen that the sum of the incoming currents is equal to the sum of the outgoing currents. Correct? One particular node ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ, one point ಅನ್ನು, ಅಲ್ಲಿ sum of the incoming currents is equal to the sum of the outgoing currents. Right? So just apply it. Apply KCL. KCL ಅಂದ್ರೆ Kirchhoff's current law at node B. Node B ಅಂದ್ರೆ ಯಾವ್ದು? ಇದು. Yes, ಈ ಪಾಯಿಂಟ್ ನಲ್ಲಿ ಯಾವ ಕರೆಂಟ್ ಬರ್ತಾ ಇದೆ, ಯಾವ ಕರೆಂಟ್ ಇನ್ಕಮಿಂಗ್ ಇದೆ and ಯಾವ ಕರೆಂಟ್ ಔಟ್ಗೋಯಿಂಗ್ ಇದೆ ಅನ್ನೋದನ್ನ ನೋಡ್ಬೇಕು ನಾವೀಗ. ರೈಟ್? ಸಿ, ನಮಗೆ ಗೊತ್ತದ ಪಾಯಿಂಟ್ ನಲ್ಲಿ ಎಂಟರ್ ಆಗ್ತಾ ಇದ್ರೆ we must take them as a positive. ಹೌದಾ? ಸಪೋಸ್ ಇದು ಪಾಯಿಂಟ್ ಅದಪ್ಪ, ಈ ಕಡೆಯಿಂದ ಒಂದು ಕರೆಂಟ್ ಬರ್ತಾ ಇದೆ, ಸೊ ಅದನ್ನ ನಾವು ಪಾಸಿಟಿವ್ ತಗೋಬೇಕು. ರೈಟ್? ಸಪೋಸ್ ಒನ್ ಕರೆಂಟ್ positive I1. Yes, so plus I1. Next minus I3. ಯಾಕಪ್ಪ it is outgoing current. ಹೌದಾ ನೋಡಿ ಕರೆಂಟ್ ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದೆ. Yes, so minus I3. Then Ig ಇದು ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದೆ. So minus Ig is equal to 0. ಯಾಕಂದ್ರೆ ನಾವು ನೋಡಿ summation I is equal to 0 ಅಂತ. Algebraical sum of the currents is equal to 0 ಅಂತ ಕಲಿತಿದ್ವಿ ನಾವು law ನಲ್ಲಿ. Yes, that's why I took here 0. So ಇಲ್ಲಿ ನೋಡಿ ಇವೆರಡು ಮೈನಸ್ ಇವೆ, ಆ ಸೈಡ್ ಕಳಿಸಿ. So I1 is equal to I3 plus Ig, but Ig is equal to what? 0. Already you know that. So here I will write I1 is equal to I3. So take it as equation number 1. ಇಲ್ಲಿ ತಗೊಳ್ಳಿ because Ig is equal to 0. Correct? Yes. Similarly, now KCL law at now apply KCL Kirchhoff's current law at node D. ನೋಡಿ ಆಗಲೇ B ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ, ಈಗ D ಗೆ ಅಪ್ಲೈ ಮಾಡಬೇಕು. Apply it at point D. What you will get? See, who is the incoming current? Incoming current ಯಾವ್ದ್ರಿ? I2. ಹೌದಾ? Incoming current I2. So plus I2. Then ಮತ್ತೆ ಯಾರು? Ig ನು ಬರ್ತಾ ಇದೆ. So plus Ig. Then outgoing current ಯಾರು? I4. Correct? So take it as minus I4 is equal to 0. Once again I will tell. See point D ನಲ್ಲಿ incoming current ಯಾರು? I2. Ig ನು incoming ಇದೆ, ಬರ್ತಾ ಇದೆ. Yes, so ಅದಕ್ಕೆ value plus I4 ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದೆ, outgoing current. So minus. So here Ig will be 0. I2 is equal to I4. Take it as equation number 2 because Ig is equal to 0. Correct ನೋಡಿ? Write it as yes. Now ಈಗ Kirchhoff's current law ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ. Now second law, Kirchhoff's voltage law. ಹೌದಾ? ಅಲ್ಲಿ ಒಂದು ಟ್ರಾವರ್ಸ್ ನೆಟ್ವರ್ಕ್ ಅನ್ನು ತಗೊಂಡಿದ್ವಿ, ನೆನಪಿದ್ದೀರಿ? Yes. Similarly, apply KVL Kirchhoff's voltage law to mesh A B D A. ಹೌದಾ? Yes, A B D A. ನೀನೆ ಈ ತರ ಒಂದು ಹಾಕಿದ್ದೀರಿ ಟ್ರಾವರ್ಸ್ ನೆಟ್ವರ್ಕ್ ಅನ್ನ. Yes, ಈಗ ಹೇಳಿ ಏನೇನು ಬರ್ತದ? That is product of the IR is equal to EMF ಅಂತ ಇದೆ. Yes, so ಈಗ ನಾವು I ಮತ್ತೆ R ಎರಡು ಕೂಡ ತಗೋಬೇಕು ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ, ರೈಟ್? ಸೊ ಈಗ along the direction of this ಇದ್ರೆ ಪಾಸಿಟಿವ್, ಇದಕ್ಕ ಉಲ್ಟಾ ಇತ್ತಂದ್ರೆ ಸಾರಿ ಅಪೋಸಿಟ್ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತದ? ನೆಗೆಟಿವ್ ತಗೋಬೇಕು. Yes, so along the direction, see ಇದು ಹೇಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ? ಈ ತರ ಕ್ಲಾಕ್ವೈಸ್ ಇದೆ. Yes, so ಇದು ಈಗ ಕ್ಲಾಕ್ವೈಸ್ ಇದೆ, ಸೊ ಪಾಸಿಟಿವ್ ತಗೋರಿ. ಇದಕ್ಕೆಲ್ಲಾದ್ರೂ ಅಪೋಸಿಟ್ ಇದ್ರೆ ಮೈನಸ್ ತಗೋರಿ, ರೈಟ್? ಸೊ ಜಸ್ಟ್ ಸಿ I1 R1 ಪಾಸಿಟಿವ್ ಬರುತ್ತೋ ನೆಗೆಟಿವ್ ಬರುತ್ತೋ? It will be positive because it is moving along with the traverse network. So I1 R1. ಹೌದಾ? ನೆಕ್ಸ್ಟ್ Ig ನೋಡ್ರಿ, Ig ಮತ್ತೆ G ಅದು ಇದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ, ಇದರ ಜೊತೆನೇ ಇದೆ. ಸೊ ಪ್ಲಸ್ Ig into G, ರೈಟ್? ಈಗ ನೋಡಿ ಮೈನಸ್ I2 ಮತ್ತೆ R3 along the direction ಇದೆಯೋ ಇಲ್ಲ ಅಪೋಸಿಟ್ ಟು ದಿಸ್ ಇದೆಯೋ? ಇದ್ರ ನೋಡಿ ಡೈರೆಕ್ಷನ್, ಇದ್ರ ನೋಡಿ ಡೈರೆಕ್ಷನ್, ಎರಡು ಅಪೋಸಿಟ್ ಅವ. ಸೊ ಟೇಕ್ ದ ಮೈನಸ್. ಸೊ ಮೈನಸ್ what you get here? I2 R3 is equal to 0. Correct? Yes. Ig ಅಂತೂ 0 ಇದೆ. So I1 R1 plus 0 is equal minus I2 R3 is equal to 0. So minus and R side ಕಳಿಸಿ, it will become plus I2 R3. ನೋಡಿ ಕರೆಕ್ಟ್ ಇದೆನಾ ಇಕ್ವೇಷನ್? Yes. Ig into G, Ig will be 0. The 0 into anything, that is 0. So take it as equation number into G is equal to 0. Correct? Yes. So I3 R2 minus I4 R4 minus 0 is equal to 0. Ig is 0. So I3 R2 is equal to I4 R4. Correct equation now? Yes? Yes. Now what we will do? We will change the some currents here. How? Just see. But from equation 1 and 2, what is that? I1 is equal to I3 and I2 is equal to I4. Nodi, ide thara ide. Yes. So now we ಮಾಡಬೇಕು I3 ಮತ್ತೆ I4 ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಚೇಂಜ್ ಮಾಡಬೇಕು. Yes. So I will change here. So I3 ನಲ್ಲಿ I1 ಹಾಕ್ತೀನಿ. I1 R2 is equal to I4 ಇದೆ, it will become I2, then R4. So take it as equation number 3 and it is equation number 4. Correct? Yes. Now I will rub this. Now divide equation 3 by 4. ಹೌದಾ? equation 3 ಏನಿದೆ ನೋಡಿ, I1 R1 divided by I1 R2 is equal to I2 R3 divided by I2 R4. Correct ಇದೆ ನೋಡಿ? Divide equation 3 by 4. So here I1 will get cancelled, I2 will get cancelled. So what remains? R1 by R2 is equal to R3 by R4. So this is our main equation. Now ಇದನ್ನೇ ಹೇಳಿದ್ದೀನಿ ನಿಮಗೆ ಫಸ್ಟ್ ಗೆ. Yes. So ನಾವು ಮೀಟರ್ ಬ್ರಿಡ್ಜ್ ಇಂದ ಏನು ಮಾಡ್ತೀವಿ? We compare the resistance. Yes. If you know the resistance R1 and R2, easily you can calculate the value of R3 and R4. ಹೌದಾ? Suppose if you know only R1, then R2 ಈ ಸೈಡ್ ಕಳಿಸಿ, R2 R3 divided by R4. Yes. So easily we can calculate the unknown resistance. ಹೌದಾ? ಇದು ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಇದು ಗೊತ್ತಿದೆ, ಇದು ಗೊತ್ತಿದೆ. These are the known resistances. Yes, but we don't know this one, so it will become unknown resistance. Yes. So by this equation we can compare the resistance from this equation, and also we can calculate the unknown resistance by using this equation. Right. So this is all about the Wheatstone's bridge. Yes, ಇದು ಬಹಳ ಈಸಿ ಇದೆ ರೀ. ಜಸ್ಟ್ ನಿಮಗೆ ಯಾವ ಸೈನ್ ಅನ್ನ ಹೇಗೆ ತಗೋಬೇಕು ಅನ್ನೋದು ಗೊತ್ತಾಗಬೇಕು ಅಷ್ಟೇ. ರೈಟ್. Once again, if you not understood anything, then again you watch the video.